Welcome to this module, where we explore how effective operations and maintenance shape the long-term performance, safety, and profitability of solar PV plants. As solar power grows globally, proper O&M is essential to protect investments, improve energy output, and extend equipment life. In this module, we break down common system issues, cost implications, preventative and corrective maintenance, and the importance of performance monitoring. And above all, we highlight the critical role of health and safety in every O&M activity. Let's begin your journey to mastering cost-effective and reliable O&M for solar PV plants. Solar PV systems are designed for long-term generation, but protection and maintenance are essential to ensure safety, reliability, and maximum power output. Here we will discuss the main protection systems, maintenance types, performance indicators, troubleshooting methods, and safety practices for PV plants. Key points: ensure safety and reliability of PV assets, minimize downtime and energy loss, extend component life via periodic inspection and testing, optimize plant performance and ROI, safety of personnel. PV plants require electrical protection to prevent damage due to faults and environmental threats. The main protection categories are overcurrent, overvoltage, surge, earthing/fault protection, lightning protection system, LPS, and anti-islanding, DC side protection, fuses, DC isolators, DC SPDs, AC side protection, MCBs, MCCBs, earth fault relays, AC isolators. Surge protection devices, SPDs, protect sensitive electronics from transients. Earthing systems. Separate earthing for DC, AC, and lightning protection as needed. Lightning protection system, LPS. Air termination, down conductors, and earth termination. Anti-islanding. Inverter functions to cease exporting when grid is lost. A typical PV plant lifecycle extends 25+ years. O&M activities vary by phase: design/commissioning, operations, routine O&M, and end of life, repower/decommission. At the end of the useful life, the plant may have to undergo renovation and modernization, R&M, based on the requirements and available technology. Design and installation, QA/QC, correct layouts, proper earthing and protection design. Commissioning, functional tests, pre-commissioning checklists, anti-islanding tests. Operation, daily monitoring, scheduled cleaning, preventative maintenance. Decommissioning/repowering, replace degraded modules or upgrade inverters. Effective maintenance of the plant along with a good house. Keeping maximizes energy yield, prevents failures, supports warranties, enhances safety, and reduces long-term costs. Maintains peak energy production, detects and corrects issues early, lowers risk of catastrophic failure, preserves warranties and contractual performance guarantees. Key indicators quantify plant performance and detect problems early. Let's look at the 3 indicators that tell you how healthy your solar plant really is. Ratio of actual energy produced versus theoretical max. Shows system efficiency after real-world losses. Assesses inverter performance and losses. Contractor KPIs ensure operational accountability and performance. Response time for breakdowns. Target X hours. Scheduled maintenance completion rate, PR, target achievement, % per month. Mean time between failures, MTBF. Plant availability/uptime percentage. Uptime is the percentage of time a plant is operational. High uptime equals higher energy production. Uptime, % equals operational hours divided by total hours times 100. Downtime includes planned maintenance and unplanned outages. Track both planned and unplanned separately for root cause analysis. Example: In a 30-day month, that's 720 total hours. If operations run for 711 hours, then uptime equals 711 divided by 720 times 100 equals 98.75%. O&M falls into three main categories: preventative, corrective, and predictive. Preventative: scheduled cleaning, inspections, tightening, lubrication. Corrective: reactive repairs, part replacement after failures. Predictive: condition-based maintenance using analytics, IV curves, thermography, vibration, IoT sensors. Routine activities keep the plant healthy, from daily monitoring to annual thermography. Simplified schedule: PV modules. Clean the PV modules with mild soap and water on a fortnightly or site-dependent schedule carried out by the user or technician. PV array: perform an annual visual inspection of the PV array to ensure all components are intact and functioning. Junction boxes: inspect all junction boxes annually for any signs of moisture entry or corrosion, done by a qualified electrician. Wiring: check wiring insulation and electrical connections annually to maintain system safety and performance. Inverter: conduct a monthly visual check of the inverter and review any error codes or alarms, handled by an electrician. Instruments: validate instruments such as the pyranometer and other sensors annually with the help of a PV specialist. Transformer: carry out annual oil level checks and connection inspections on the transformer, performed by an electrician. Tracker, if installed: inspect and lubricate all tracker components twice a year to ensure smooth and accurate tracking. Plant monitoring: monitor the plant performance daily and maintain proper logbook entries, overseen by the site in charge. Spare parts: manage and update the inventory of critical spare parts as needed, handled by the site in charge. Each component has specific checks: modules, racking, inverters, cables, earthing, RMS. Modules: clean visual inspection, IV curve testing, check for micro crack/hotspots. Mounting and racking: check for corrosion, bolts, alignment. Inverters: firmware updates, fan and filter cleaning, terminal torque checks, error log review. Cables and wiring: look for abrasion, loose lugs, discoloration, overheating, insulation resistance tests. Earthing: periodic earth resistance measurements and tightness checks. Remote monitoring system, RMS: validate sensors, calibrate pyranometers, ensure data integrity. Safety protects personnel and assets, always mandatory during O&M. Use PPE, insulated gloves, safety helmets, safety shoes, harnesses for heights. Apply lockout/tagout before electrical work. Ensure isolation and earthing before maintenance on live systems. Maintain emergency response kit, first aid and firefighting equipment. Train staff on fall protection and electrical hazard recognition. Troubleshooting uses data and field tests to locate faults quickly and safely. Use IV curve analysis to detect string/module underperformance. Thermography identifies hotspots or bad connections. Check inverter error logs and alarm history. Carry out root cause analysis, RCA, and failure mode and effects analysis, FMEA, for recurring issues. Prioritize maintenance using cost and risk metrics: criticality priority number, CPN, and risk priority number, RPN. CPN, cost priority number, equals cost times downtime impact times frequency, simplified metric. RPN, risk priority number, equals severity times occurrence times detection, FMEA metric. Higher CPN RPN, higher priority for preventative or corrective action. O&M faces remote site access, skilled/semi-skilled manpower constraints, large area coverage, climatic issues and logistics, New trends. Artificial intelligence, AI, drones, robotics help address these challenges. Remote access and logistics for large plants. Shortage of trained personnel for analytics. Supply chain and spare parts management. Integration of predictive maintenance, AI/ML. Use of drones and robotic cleaning for scale. Protection and maintenance keep PV plants safe, efficient, and profitable. Regular monitoring, effective safety protocols, and modern predictive tools reduce downtime and improve lifetime yields. Regular preventative O&M preserves energy yield and asset life. Safety and compliance must be followed at all times. Data-driven predictive maintenance reduces unplanned downtime. Prioritize work using CPN/RPN to maximize ROI. NREL, Best Practices for Operation and Maintenance of PV and Energy Storage Systems, 2018. ADB, Handbook for Rooftop Solar Development in Asia. IFC, Utility-Scale Solar Power Plants, Guide for Developers and Investors. Thanks for going through and reading. Don't forget to like, share, and subscribe for more solar insights from I-SED Academy. Please go to I-SED Academy platform for detailed learning about solar technologies.